music is just kind of, ooh, it's eerie, spooky. The angst level is up in the room. No angst. What?
The only thing he was like, I don't know, I just feel terrified.
Oh, yeah. Wow. That's pretty daggone impressive right there. Okay, so, gotta like that. Nicole, can you take us through what you did? You don't sound too sure about that, Nicole. Well, take us through the process you did. That's a legitimate approach. Why not? Why did you not pick certain ones? How's that?
Well, the green one, the log bases were switched.
Okay, right. So you should have a log base 4 in the numerator, or log base 2 in the numerator. That's right. So you took that one out. That's good. Okay, what else?
The blue one, I just didn't know where that 28 and 10 came from.
Ah, okay. So where would you normally take the 7 and the 4? Where would they go? Instead of multiplying together, where do they normally go if they're out in the front and you're bringing them back inside?
Exponents.
As exponents, yeah. So they wouldn't multiply together. So that's a good way of getting rid of that one. Sure. And then how did you decide it wasn't the red one?
Because there was no exponents.
There was no exponents in there. Yeah, that's right. Yeah, that's a good process of elimination. I don't have any problem with that. That's no big deal. How many times when you have exams in college are they multiple choice anyway? Right? There are quite a few that usually are. Yeah, yeah. Quentin, looks like you have green over there too. What way did you do it?
I quickly looked at the x, and then the 7 would be the exponent.
Okay.
The 4, the y exponent.
Okay.
I saw the difference in the logs in the, I guess it doesn't matter because it would be numerator and denominator.
Okay.
And so I took the 2 to the z there, and then the w to the 5.
Okay.
And then I just combined, or I figured out that the addition would be multiplication. And
Okay.
the subtraction in the denominator would be a division, or the subtraction.
Yeah, the subtraction would be a division. I knew what you meant. Like so, yeah.
Yeah, and then that was pretty much it. I could figure it out.
Yeah, that's right. That's absolutely right. That's not an easy problem. It really, really isn't. Okay, so here we go. Final results. Ooh. Very nice. Very nice. Those were hard. Those were not easy. I don't think this general section is all that easy, to be honest. It's hard to be able to think in opposite directions when you're working on this sort of stuff. But it's crucial for when we're solving log equations that you know how to split things up and recombine things, which you're going to see today. How do I do that? All right? So congratulations to our podium winners. Well done. Well done. And I think all of you learned something taken away from it. Maybe some things that you need to work on between now and next Tuesday when we take our test. And you have maybe some things when you look at the learning targets that'll be on Canvas, you'll go, okay, here's some things that I need to ask him about as we're getting closer and closer to the test itself. A key property is the following. If you have log base A of m equals log base A of n, so you have the log of a lump on the left and a log of a lump on the right, and the bases are the same, all you have to do is set the interiors of those two logs equal to each other and solve. It would be like you were solving a regular equation, you were trying to get rid of the same thing on both sides. It's true, that's the same thing is going to happen. Okay? So we're going to drop down to number 3. And number 3 in the notes looks like the following. It says log of 3x minus 3 minus log of 4 equals log of x plus 1. Now, what's the base on something when I don't give you the base? 10, yeah, that's the common log we talked about yesterday that has a lot of applicability to all sorts of different scientific situations. Now, the goal that you want to try to do is you want to try to have the log of a lump on the left and a log of a lump on the right. This is where you have to use those log properties that we just did a Kahoot on. Okay? So what does this subtraction sign that's right there tell you that you're going to end up doing with those two things on the left? TL, say again? Dividing, right, because when you divide two things, you subtract the exponents. Yep. So now I have log of a lump. I know you all love that phrase, log of a lump, right? Log of a lump on the left, and you have log of a lump on the right, like so. You've reached that place where you can actually use the property that says if you have log of a lump and it equals a log of a lump, those log expressions can go away. And now you're going to have 3x minus 3 over 4 equals x plus 1. And you're trying to solve that for x. What would you do? This is just an algebra thing now. Cross multiply, and how do you know you're going to cross multiply? What's under the x plus 1? Yeah, there's a 1. And now you have two fractions? Right. Okay, so cross multiply that for me. Bill, what'd you get when you cross multiplied?
X equals -7.
Well, the first step in cross multiplying anyway. I know that's the right answer, but.
3x minus 3 equals 4x plus 4.
Okay, there's the cross mult.
Add the 3.
Add the 3 and subtract the 4, okay. So you get negative x equals 7, x equals negative 7. Now I can tell you that my answer key for that problem does not list negative 7 as the answer. It lists that as the answer. Let's talk about why that is the answer, why no solution is the answer. You can't ever take the log of a negative number. So when you plug this answer of x is equal to negative 7 back into either of these places, if you get the log of a negative number, you can't do that. And I'll tell you the reason why. If you're raising 10 to a power, and you're supposed to get like a positive number sitting over there, well, let's do it this way. You can't have 10 to a power equaling a negative number, ever. Right? What's a positive number to a power always going to be? It's always going to be positive, right? It can never be negative. So when you're actually putting that negative inside of here, like this side, you're saying log base 10 of, what would it be, negative 6? I cannot think of a power I can raise 10 to get negative 6. That is not possible. Over here, same deal. If I put a negative 7 into there, I'm going to get log base 10 of negative 24. You cannot raise a positive number to a power and get a negative answer. That is impossible. So what you have to watch out for is you can't take the log of a negative number. So when you're going through and you're working on a problem, the very last thing to do is check, am I taking the log of a negative number when I plug back in? Physically, it is not possible to raise a positive number to a power and get a negative. There's no way. All right? Now, with that kind of idea, I'd like for you to try number 4 on your own or actually in groups and see if you can come up with the correct answer. And what I'll do is I will put the correct answer up here. So you work it out, see if you and a partner can come up with the same answer. You're still doing the same thing. Left-hand side, you want to try to make the log of a lump. The right-hand side is already a log of a lump. Or actually, it's the left-hand side that's a log of a lump. The right-hand side, you need to figure out how to combine it. This is the problem you're working with. And I'm putting the bases of 10 in there for you, since they're common logs again. So on the right-hand side, you want the log of a lump. Once you have the log of a lump on each side, you drop the logs and then solve what remains. And I will give you an answer down here.
Isn't it flipped?
Hmm?
Isn't it 9 over 2?
Is it 9 over 2? It's flipped the other way? No, because you're going to divide both sides by 9. Because you want to get rid of the number that's in front of the x. But you combined it right, Maddie. You just flipped it over was all. Very nice, Nicole. Well done. Nice. Mm-hmm. Did you figure it out?
Yeah, because I forgot about that x. So that would make it.
Oh, that's over there? Yeah. Yep. Yep. Tyler's got it. Nice. How we doing over here, y'all? Got it, Drew? Oop. What are you going to divide both sides by there?
9. 2 over 9.
So it's 2 over 9 instead of 9 over 2. Yeah. 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 You got'd it.
So when we plug it in, would we put in log?
I just took my cord off. That's okay.
So would we plug this into the whole thing or just like one?
Any place there's an x.
Okay. So then it would be this log button.
Why are you plugging it back in?
What she's doing, Kim, can you explain what you were doing there? You were making a comment about this 2/9 and what you were doing with it.
Like
So,
I have to plug it in to make sure that it doesn't equal
a negative number?
negative number. Yeah.
Okay, so you can do it this way if you want to. If I plug that back up into there, is the interior of the log positive? Yes, so that one should be okay there. If I'm plugging it in there, 5 times a positive number is still positive. If I add 1 to it, that's still positive. So I'm not taking the log of a negative number anywhere.
So you'd have to plug it into each one.
Mm-hmm. And if either one gives you the log of a negative number, then we have an issue. Okay? So it all looked good to me. Can we get a sort of rehash of the steps that it takes? Teal, you got yours 100% right. What did you do?
I set it equal to x plus 4 equal to 10x plus 2. I multiply 5x plus 1 by 2.
Okay, and why did you do that again? It's right.
I don't know why. I just know to do that.
What was addition originally?
Addition, it means you multiply it.
Yep. Cool. And then what'd you get? X plus 4 equals?
10x plus 1. Oops, I'm sorry, 2.
Uh-huh. Okay, keep going.
And then equal to subtracted the 2 from both sides. And then
Okay.
subtracted.
Whoops.
And it came to x2, yes. And I subtracted an x,
Mm-hmm.
which is 1, really, yeah.
Mm-hmm.
Yeah, and then divided, 9.
You got that?
Yeah.
Very nicely done. Very nicely done. Well done. All right, so the question then becomes, as we're working on that front side, what in the world are you going to do when there isn't a log over on the right side? Look at number 1 and number 2. Notice that you do not have a log over on the right.